This last lesson in the series is, I guess, maybe a strange one. Some of you may have trouble with it, but if we take it slow, I think we'll be okay. In the previous video, we talked about the fact that we can build up other power series by either plugging things into power series or by multiplying them. So for instance, if I asked you to find a power series for x e to the x, I suspect it wouldn't be that difficult, because what you guys would do is you would just note that e to the x is 1 plus x squared over 2 factorial plus x cubed, plus x cubed over 3 factorial, and so on. And then when you did x e to the x, you would simply distribute, because you would distribute the x through to every term inside of this thing, and you would get x plus x squared plus x cubed over 2 factorial plus x to the 4th over 3 factorial, and so on. This works really, really easily because I'm multiplying a power series by a polynomial, or by a constant, or by something nice. Where it gets more complicated is what happens if I have a power series times another power series. And so I have an example of that right here. What if I asked you to find the first 3 non-zero terms of the Maclaurin series for e to the x cosine x? Now, you're in luck, because I'm only asking for the first 3 non-zero terms, and that's generally how they do it. They're not going to ask you for like the nth term of something crazy like this. The way that this is going to work is we're going to write down the Maclaurin series for this and the Maclaurin series for this, and then we're going to begin to mega superfoil them together, right? So for instance, e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial forever times, and cosine is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. And so my idea here is, what do we need to do? We basically need to FOIL this out. Now, I'm not going to FOIL it out forever. I really only need to figure out what the first 3 non-zero terms are. And there are a couple of different ways to do this. A lot of it just sort of depends on how you want to organize yourself. Now that I think about it, the box method of multiplying things out actually makes a lot of sense here. I think I might try that out. Yeah, I mean, what I was going to say, the way I've taught this in the past is I've said, distribute the 1 to the first few of them, then distribute the x to the next few of them, and then distribute the x squared to the next few of them. But there's a point at which you're like, you don't really need to distribute everywhere. You can sort of stop in certain places. So I don't know how many of you have seen this, but you can sort of, set up this idea of, those of you that did Punnett squares in biology, you can sort of do the FOIL process by building a box. I really hope I'm leaving myself enough room here. I'm a little bit scared. And then in each part of the box, you're just filling in what multiplies in the nearby areas. And at first you're like, oh my god, there's no way I'm going to fill in all 16 of these boxes. Like, this is terrible. And on the one hand, you're right, it is terrible. On the other hand, I don't think we're going to have to fill all of them in, and you'll see why in just a minute. Right? So when I start multiplying these together, I've got 1. Now, 1 is a constant term, right? So, I mean, I know that my product is going to start with that, 1. Then the next thing I'd have 1 times x, which is x. And over here, I would have 1 times negative x squared over 2 factorial, which is negative x squared over 2 factorial. Now, this is where it sort of gets fun. If you look at what's going to be multiplied in all of these boxes, are you ever going to get another constant term? Or another x to the first term? No. This is going to be x squared, this is going to be x cubed, this will be x cubed, this will be x to the 4th, this will be x to the 5th. Like, they're all going to be bigger than that. So our first term is already 1. My next term is already x. The next one is going to be squared, but I need to be a little bit careful here. Will I get a squared term anywhere else? I will. There will be a squared term here. It's going to be x squared over 2 factorial. Will I get x squared terms anywhere else? That one's cubed, that one's fourth, that one's cubed, that one's fourth. I'm not going to get any more squared terms, and so this is actually interesting. These are opposites of one another and therefore drop out. So I need to go a little bit further, right? So let's see here. This one on the bottom left is x cubed over 3 factorial. I can also get an x cubed term here. That one's going to be negative x cubed over 2 factorial. Sorry, that's a really ugly 3. Let's see, 3. Remember, this is going to be squared times squared. This is x to the fourth. This is fourth times first. This is x to the fourth. These are the only two x cubed terms. So I'm going to have minus x cubed over 6 plus x cubed over 2. And all the rest of this, I don't need to fill in because they only wanted the first 3 terms. All I have to do is finish simplifying this. 1 plus x. If I got a common denominator here, I would end up with plus x cubed over, it's actually not x cubed, sorry. Actually it is. This is going to be 3 6, so you'll have 2 6s. So yeah, it's going to be x cubed over 3. This is my third term approximation for e to the x cosine x. That seems a little odd. Oh, I see what I did wrong. Sorry, I do have a mistake in here. The one with a 6 in the denominator was actually positive. So this should have been positive. And this one here should have been negative because it was negative up here. Hopefully you guys caught that as you're going through it and wondered what the heck I was doing. The subtraction there still works. It just means that this sign down here at the end is going to be a minus sign. So we'll have a minus there. So there it is. Those are the first 3 terms of this series. And so I suppose technically this shouldn't be an equal sign. This should be, an approximate symbol. But that's the idea. Admittedly, it's a lot more difficult than the other thing. But it can be done. We can take an infinite thing and an infinite thing and multiply together the beginnings of them to get what the beginning of this is going to be. I'm going to go ahead and, if you want to go through one more, I'm going to go ahead and put one more of these up on the screen. Actually, you should look at least the first, watch 1 more minute, because this next one is weird. What if I asked you the same thing? Find the first 3 terms of sine x over 1 minus x. Now this one you're like, oh my god, you're going to make me divide these things? That's terrible. No, I don't think I'm ever going to ask you to divide unless you're dividing by x, where you can just cancel an x out of everything, which you guys saw in the previous video. What I want you to do is think about this as multiplication. Think about it as sine x times 1 over 1 minus x. Do we know a power series for this? We do. We memorized it in the first video. Do we have a power series for this? I hope you recognize it. That's from 2 days ago. This is an infinite geometric series. It has a first term of 1 and a common ratio of x. So we should be able to write those things down and do the same thing. So if you'd like to try this one out and see the answer, go for it. If you want to just watch me go through another example, that works too. I'm going to do that now, and I'm going to try and do it quickly. Sine x is supposed to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. I don't think I'm going to need more than that, so I'm going to stop there. My other one has first term of 1 and a common ratio of x, so plus x squared plus x cubed. I'll go to that one just in case I need it. When I FOIL those, I'm going to use my sort of box method. I'll put the first terms down the side. X to the 5th over 5 factorial. And along the top, I'll put my other ones, 1, x squared, x cubed. I'll construct out my box. Now some of you may be wondering, why did I do a 3x4 box this time? I thought that this was as much as I was going to need. And I can kind of imagine what the box will look like as I'm going through it in case I need more. So now I'm just going to start multiplying things out and see what I see. There's an x here. And this is going to be an x cubed term. This is going to be an x squared term. And everything else is going to be bigger than that. So I can tell that the first term of my sine x over 1 minus x, I can tell my first term is going to be x. My next one, this box here is going to be x squared. This is going to be x cubed. This is going to be x to the fourth. This is x cubed. Sweet. This one is x squared. And I can tell that that's going to be my next one. My third one, this is going to be x cubed. This one over here will also be x cubed. It's going to be negative x cubed over 6. This one here is going to be x to the fourth, 1 and 3, so I don't need that one. This is x to the fifth, that's x to the fourth, this is x to the fifth. I'm not going to need anything else. I've got everything I need right here. All I need to do is add together x cubed and negative 1/3. I'm sorry, negative x cubed over 6. So if I just think of this as being 6/6 x cubed, I can tell my next term is going to be plus 5/6 x cubed. And those are the first 3 terms of my power series centered at 0 for this function. Hoping that'll get you guys through the beginning of the homework assignment. If you've still got some mathematical energy left, I'd recommend trying a couple problems. Like, pick one in the 2 to 7 range, one in the 8 to 9 range, one in the 10 to 11 range. Try one of each of them, make sure you've got an idea for it, or at least look at them and see if you know what you need to do before you get to class tomorrow. I will see you then.